Welcome. In this lesson, we are going to be looking at some mixed factoring. And really what we mean by that is we'll be combining the two methods of factoring that we've learned so far in Unit 11. So we've learned how to factor using the greatest common factor, as well as talking about factoring a trinomial, and that was using our factor sum tables. So we're going to go ahead and look at how we can combine those two different methods of factoring into some trinomials here. So the first thing that we're going to do is looking at factoring using a greatest common factor first, if we can. So if we can find a greatest common factor, we'll factor using a greatest common factor. Then we'll check and see if we have a trinomial. That way we can then factor a trinomial using our factor sum tables. Again, this says if possible. If it's ever not possible to factor, we would say prime. Let's take a look at example number 1. The first thing we're going to do is check for a greatest common factor. So first we'll check and look at our numbers. We have 3, 3, and 36, and 3 would go into all of those. So our number will be 3. Looking at our variables, we want the smallest exponent. So we have an x cubed, an x squared, and an x. So our smallest one would be x. So 3x will be the greatest common factor. We'll then go ahead and divide all of these terms by 3x and write our result. So our greatest common factor will go on the outside, and then in parentheses will come from when we do our division. 3 divided by 3 is 1, so that will really just go away. And then if we subtract our exponents here, 3 minus 1 is 2, so we'll be left with x squared. Again, 3 divided by 3 is 1. If we subtract our exponents, 2 minus 1 is just 1, so we'll be left with 1x. And then if we do negative 36 divided by 3 is negative 12, our x will cancel there, so this will be the result of factoring by the greatest common factor. Now, what we're going to check for is what's in parentheses. And if this is a trinomial that we know how to factor, so it looks like x squared plus bx plus c, then we can go ahead and set up a factor sum table to now factor this. Our greatest common factor is just going to stay outside of the parentheses. So even when we go to write our answer here, that 3x is going to stay outside of our parentheses, and we'll see if we can figure out two factors using our factor sum table. So we'll go ahead and set up our factor sum table. We want factors of negative 12, and then a sum. We can think of a 1 in front of that x there, so we want a sum of 1. So I want numbers that multiply to negative 12 and add to 1. Here, negative 12, I need one number to be negative. So for example, we could do like negative 4 times 3. Negative 4 plus 3 gives me negative 1, so let's check and see if we flip those. Negative 3 times 4 is still negative 12, and negative 3 plus 4 is 1. So the factors that we want will be negative 3 and 4. So I'm going to write just next to this greatest common factor here. I'll write x minus 3 and x plus 4. So we're kind of changing that trinomial by factoring that. This will be our final answer. Let's try that process again. So again, first we're always going to check for a greatest common factor. So looking at number 2, I want to check and see if we can get a greatest common factor here. We have 2 and 16 and 96, so 2 would be the biggest factor that would go into all of those. Looking at our variables, we want the smallest exponent between the 4 and the 3 and the 2. X squared would be our smallest. So our greatest common factor is 2x squared. We can go ahead and divide each term by 2x squared. I will keep that greatest common factor outside of my parentheses, and then the result of my division inside. 2 divided by 2 is 1. Those go away. If we subtract our exponents, 4 minus 2 is 2, so we'll be left with x squared. 16 divided by 2 is 8, and 3 minus 2 will just be 1x. 96 divided by 2 is 48, and our x squareds cancel, so we are done. Now we have this trinomial here. So once again, this looks like x squared plus bx plus c, and we can go ahead and use a factor sum table to simplify. Here we want factors of negative 48. That gives me a sum of negative 8. So I need one positive and one negative, and I need them to add to negative 8. So I'm going to try using 12 and 4. So if we do negative 12 times 4, negative 12 times 4 would give me negative 48. Negative 12 plus 4 would give me negative 8. So those will work as our factors. Once again, don't forget to write your greatest common factor outside to start, so we'll still keep that 2x squared. And then these factors here, this factored into a minus 12 and a plus 4. And that would be my final answer. All right, let's try one more. Again, first we'll look for the greatest common factor. We have 21, 14, and 56, so 7 would go all of those. For m's, I want my lowest exponent between 4 and 5 and 2. That would be m squared. And n's, here we have a 2, a 4, and a 2, so that would be n squared. And we can go ahead and divide. So we'll divide by 7m squared, n squared. And we'll write our answer. So that greatest common factor will go on the outside. In the parentheses, 21 divided by 7 is 3. Subtract our m's. 4 minus 2 is 2. And n2 minus 2 is 0, so our n squareds cancel. Next term, negative 14 divided by 7 is negative 2. Subtract our m's. 5 minus 2 is 3. And n's, 4 minus 2 is 2. Last term, 56 divided by 7 is 8. M squared cancel, and n squared cancel, so we'd be done. Now here, if we look, this is a trinomial. We have 3 terms, but this does not look like our normal trinomial. Like, it doesn't look like a squared plus a number plus a number. So this is not in x squared plus bx plus c form, meaning we cannot factor this using our factor sum tables. So we'll just say that this is our final answer. It's possible that sometimes we don't go further if we don't have a trinomial that looks like the trinomials that we factored before. So when you're doing mixed factoring, just be careful that you're paying attention to when we're able to go another step or when we have to stop.